section 6.4e, we're actually going to be solving, I didn't write the title, exponential equations in this video. And the way we do that is basically, I'm giving you some simple rules here. To solve an exponential equation at the form bx equals by, when b is greater than 0 and b is not equal to 1, solve the equation x is equal to y. So, in short, what we're going to do is we're going to set bases to be the same. I'll show you what I mean by that in just a second. And then once we set the bases to be the same, we take the exponents and set them equal to one another and solve. All right? And I'm going to put that in there. And solve. So what do I mean? So let's just go to this very first one. It says 5 to the x power equals 125. Well, here's the problem that we've got. This is my base for this one, is 5, where the base for this is 125. I don't want that. I need them to have the same bases. Well, the easiest thing for me to do is to find out what this number is with a base of 5. So I'm going to write 5x here is equal to, and let's find out what happens. I know my base is 5, so let's see what happens if I go 5 times 5. Well, that gives me 25. Let me multiply that by 5 again. That gives me 125. What did I just find out? If I take 5 and multiply it by itself 3 times, I get 125. Meaning my base is 5 and my exponent is now 3. So we can plug that in just to prove it. 5 to the third power equals 125. Now that I have both of them set to the same base, I can simply take these two things, these two exponents, and set them equal to one another. X is equal to 3. I'm done. All right? Let's do this next one. Notice that this has a base of 4 and this has a base of 2. So the best thing for me to do is to try to change this base to have a base of 2. So how can I do that? Well, I know that 2 squared is 4, and all that's being raised to the x power. Okay, just finish out this. Now, recall your rules with exponents. When I'm taking a power and I'm raising it to a power, I multiply these two things. So I can rewrite this one more time to say 2 to the 2x power. Because a power being raised to a power, we multiply. 2 times x is 2x. Now I have this expression, this equation. They both have the same base, so what I can do is I take this exponent and I set them equal to one another because they are the same thing. Now that I have that, it's just a matter of solving it like I normally would. I need this x to come over here because I want to get my x's on both sides. And I get that this will be x is equal to -3. And I am done. All right, let's do the next one. Same concept. I have a 9 being raised to the x plus 2 power, and I have a 27 being raised to the x power. So what can I get these both set to? Well, I know for a fact that I can fix this as 3 squared. So I can say 3 squared to the x plus 2 power is equal to, and I can set this with a base of 3 by saying 3 to the third power raised to the x. Now that I have that, I can go ahead and do my multiplication here because I'm taking a power and raising it to a power. So this would be almost is going to work like the distributive property. So I'm going to say 3 times 2x, that's going to be a plus 4. So I have 3 to the 2x plus 4 is equal to 3 to the 3x. Now that I have that done, set my exponents equal to one another. 2x plus 4 equals 3x. I'm going to subtract 2x on both sides, and I get that 4 is equal to x, and I am done. All right? Let's try the next one. I have 32 raised to the 1 minus x power, and 8 raised to the 2x minus 2 power. So again, I need to ask myself, what can I find with a common base? Because I've done this long enough, I know that I can do a common base of 2. All right, so 2 to the watt power gives me 32. Well, we can do it a couple ways. Let's do it on the calculator. 2 times 2 gives me, so that's 2 times I've done it. Times 2 again is 3. This would be 4. This would be 5. So this would be 2 to the 5th power being raised to the 1 minus x power. That's going to be equal to 2 to the 3rd power being raised to the 2x minus 2 power. Now that I've done that, I need to go ahead and finish out my rule. I've got a power being raised to the power, so I'm going to multiply these things, and I'm going to use the distributive property. This is going to give me a 5 minus 5x is equal to 2 to the 6x minus 6, because I use the distributive property here when I multiply. Now that I've done that, I have a common base. I can just simply set my exponents equal to one another. 5 minus 5x equals 6x minus 6. Now that I've done that, let's go ahead and start combining like terms. I'm going to move this over here by adding 6 to both sides. That gives me 11 minus 5x equals 6x. I'm going to add 5x to both sides so I can get my x's all on one side, and I get 11 equals 11x. Divide by 11 on both sides, and I'm running out of room on my paper. And I get that 1 is equal to x. And we can prove this by plugging this number back into our equations. And I can do this for all of them, but for 4, I will show it to you just so you can see that it does indeed work. So I'm going to say 32 raised to the 1 minus 1 gives me 1. All right, let's do 8 raised to the 2 times 1 minus 2. What's that give me? Also 1. So this does indeed check out. And I can do this for all of these, but I won't for the sake of the time of the video. So the hardest part about this is just working things out and trying to remember what base that you could use to get 1 power. Now, I've done this fairly fast. I've done this in about 7.5 minutes, and it's because I've done this a lot. I have done this a lot, so I can figure out most of this. However, on your assignment, please take your time and ask questions. This is not an easy assignment, okay? All right, so as always, ask questions, and I'll see you in the next video. Bye-bye.